There are two places where you're going to get your data from. Your most likely is going to be sample, but now and again you get all your data because you asked every single person in the population. If you're going to get the mean, don't we use X bar to represent the symbol that means the mean? And in this case, pretend you did a sample and the mean was 40. Do you remember what letters you use when it was the population mean? Because this is essentially the sample mean. But what letter did we use when it was a population mean?
The backwards Y thing?
Yeah, it's called mu, but the backwards Y thing, it works well. And, you know, let's pretend it was 38. Now, there's another measurement. This is a measure of center. And there's another measure called the measure of spread. And it's called the standard deviation. Okay, DEV for short, standard deviation. In this textbook, they're using the letter S. So let's say it was 3. I don't think I mentioned to you the letter that you use when it's a population, but it's this letter that looks like an O with a little baseball cap on it, right? Does anybody know what that Greek letter is called?
Is it sigma?
It is. Because I think there's a question there, or there's at least one, something to do with population and sample, and what do you call which, and what do you call the other? It's one of those, you know, there's 4 answers and you pick the right dot. So there's a question that's got something like that involved in it. So I'm putting that there just for reference. So we're going to look at, today we are going to look at standard deviation and interquartile range as the 2 major measures of how spread out something is. We're also going to look at what are called box plots and how you can draw them and how you can use them to compare each other and how you can describe the distribution in a box plot. You know, what kind of shape has it got? So let's start with a set of data. One, 2, 3, 4, 5, 6, 7, 8, 9. Right. If I wanted to find the mean, the standard deviation, Q1, the median, Q3, maximum, minimum, lots of different things. For a very small data set, I could probably, with the exception of the standard deviation, I could probably do them by hand, right? They're not that difficult. The standard deviation is ugly no matter how small the data set is, so you should always use your calculator for that one. So let's do that. Let's do putting in again, it's again an overlap, and collecting all that information, then we'll see what we can do with that fella. So if I can do my usual pause and look, you should be looking at my calculator, right? My emulator. I have put a link up to that now, so if you want to use the Wabbit one, you can. There are other links as well. So I'm going to hit on. I'm going to hit.
Say really quick.
Yes.
I have a TI-36, and it has the data functions as well, so you don't necessarily need a TI-84 if you have a lower calculator.
Is it relatively easy to work with? Can you get all the Q1s and Q2s and Q3s? I don't know that calculator. I'm not familiar with that.
Yeah, it has the same. It's almost exactly the same function as the TI-84 and the TI-36.
Right, perfect. So yeah, there's another option. Is that a cheaper one to buy?
Yeah, it's less expensive.
That's good as well. So there's another option for you. There's an emulator here if you don't have one. I believe this particular emulator allegedly can be used on an Android, so you can use it on your phone as well. So whatever way you've got it, you got this guy. I'm going to hit start. Number 1 is edit, and I'm going to type in this set of data, which is 1, 3, 2 7s, an 8, a 9, and an 11. A 15 and a 19. So there should be 9 numbers, right? Because that's going to be my 9th number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm pretty sure I got everything that I should have done on that. So I'm going to hit start again. I'm going to go over to calc and do one variable statistics. And in my case, blue button 1. And we are good to go. So the mean in this data is about 8.9. The standard deviation has 2 flavors, just to remind you. We will assume that this data is a sample data. So you use this one here, right? The SX one, and it's about 5.6. If you were told that the data was actually the entire population, you would have used this one. There's 9 numbers, as you can see. And now if I scroll to the second page, here we go. I have a Q1 of 5, a median of 8, and a Q3 of 13. And I now have all my data. Are we comfortable about how to use whatever calculator method that you're going to use to collect this data? Because a lot of questions, here's some data and they have little boxes, mean, standard deviation, whatever, right? Are we cool about that? Right. Now, I hope I told you, and if I have, you will tell me. Did I tell you how you can use only the values of the median and the mean to decide if the shape is symmetric, skewed right, or skewed left? Can you remember that? Okay, so here we go here. I have an 8.9 for the mean, and I have an 8 for the median. So if I imagine my data, here is 8, here is 9, this is 8.9. And there's a little bit of a judgment call here, but would you agree that 8 and 8.9 are pretty much the same kind of number? And when they're roughly equal, as they are here, won't you expect to see a symmetric distribution?
Yeah.
Right. If this had been 18.9, right? If the mean had been 18.9, wouldn't it have been skewed to the right? And if it had been 1.9, it would have been skewed to the left. So you can sometimes get questions where you put those 2 pieces of information together and they say, what kind of distribution does this look like, or would probably look like? That's how that would work. So are we comfortable with that piece of the puzzle? Right. Now, what I'm going to do is I'm going to focus only on these guys, and I should have thought ahead, so I'm now going to. The minimum is 1, and the maximum is 19. And I am going to create a box plot of this guy, and we'll look at what kind of shape it would end up looking like. So you draw a straight line. You look at your smallest number, in which case it's 1, and you look at your biggest one is 19, and you make a kind of little judgment call. I think it would make sense to start at 1. Start at 0 and finish at 21. So you do a scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And you put along the bottom, whatever this is, let's make this scores in a test. Now, the smallest number is 1. So at 1, you do a tiny little mark like that. Q1 is 5. So at Q1, you draw a bigger line. The median is 8. So at 8, you draw another line. Q3 is 13, which is about here. You draw another line. And Q3, the maximum, I should say, is 19. And you draw a little line. And then the three big guys get you the box. And the two little guys get you the whiskers. And that's why I like the name Box and Whiskers. It kind of looks like a cat with some whiskers sticking out, right? Here's its nose, its little whiskers. So a bit, God, what do they call it now? I believe this book calls it is it a box plot? They just call it that, something boring like that, a box something. I think it's called a box plot. And this is what the guy looks like. Now, you can get a lot of information from this. In fact, if you're really good at the scales, shouldn't you be able to find the 5-figure summary? Minimum 1, maximum 19, Q1 at 5, the median, Q2 at 8, Q3 at 13. Does that all kind of, the information works quite well. It's pretty quick to draw. And you can get quite a lot of things from this. Can you see, you can tell the spread of the test scores? Can you see that the middle box right here kind of represents where the half of the class live, right? Half the class gets somewhere between 5 and 13 in this test. Right, Q1, the first a quarter, Q2, the second, Q3, the third, Q4, the fourth. So I can look at that information. I can look at it and say, yeah, the typical person probably got 8 in this test, which wasn't very good. The best person got 19. Somebody didn't know what the test was about and got 1. It's roughly symmetrical. You know, if I was trying to draw this picture, couldn't I imagine something like that? Yeah, a single hill, symmetric, like we said. So now I'm going to show you how you can tell what kind of distribution. Symmetric, skewed left, skewed right. If a shape has that. Some shapes don't have any name to them. Can you imagine a distribution that's just random bumps up and down and there's no plan or method or anything? They don't have a name because they don't have any shape worth describing, right? They're just random. But here are 3 basic box plot shapes. 1. Oh, shooting space. When you do it in pen, you can't fix your mistakes. I will do this again. That one I was happy with. There we go. I've tried to put the boxes where the middle half is actually the same one, just for comparison purposes. But each one of these box plots would generate a different shape. It would either be symmetric, skewed right, or skewed left. And you can actually make a pretty good judgment call only based on this. Now, do you notice that both these are roughly the same size and both these are roughly the same size? What do you think a shape that has that kind of box plot would be?
Symmetric.
Kind of makes sense. Wouldn't you expect it to be symmetric? So if you did histograms of it, you'd probably see that, wouldn't you? Now, this big box plot is definitely not symmetric. Do you notice this tail here is very long and the box is not evenly split? More of the box is on one side and less on the other. And do you notice that on the right-hand side, the tail is quite small as well? So big, big, small, small. What kind of shape do you think that would be?
Skewed left.
I'm going to put you in the spot. You're perfectly correct. Tell me why. What was
Well,
in your head?
The tail that is more on the left side, the data would be skewed onto the left. More data on the
Makes
left.
sense? That makes sense what you're saying? The tail. Right. So if you drew this guy, it'd be really quite long on this side and not much happening on the other side. The long tail. And the box has to follow it. You notice that this box is more on one side than the other. Now, don't you do that one? You know it's going to be called, don't you? It's going to be skewed right. So it would be more like that, right? Now, what happens? Well, I'm going to phrase this differently than what happens. When there's a contradiction in the information, do you see how this tail is really long? So it makes you think maybe it's skewed right. But do you know the box is split the wrong way? Big on the left and small on the right. That's, I abbreviated that because the thing I was going to write was too long-winded. I'm not saying it doesn't have a shape. I'm saying it doesn't have a shape that has a name, right? It's not skewed left, it's not skewed right, it's not symmetric. Can you imagine it's just some random data that just weird bumps and hills all over the place and there's no rhyme or reason to it. So I'm saying no shape, I guess, no named shape, whatever you want to call it. I guess if this was a box question, wouldn't one of the circles say symmetric? Second one would say skewed left, the third circle would say skewed right, and the fourth one would be none of the above or something like that, so that you could choose that if you got a box plot that was not of the first three types. Now let's look at a box plot in comparison to another one. And I'm just going to put some numbers here. Zero. Right, so I'm just putting numbers in those positions just so that I don't have to draw my number line. So what we have in this story are two classes called A and B. And they were given a test, and the test was out of 100. And this is what the box and whiskers of Class A's scores look like. And this is the box and whiskers of Class B. And we're going to look at compare and contrast. Well, let's start off with a comparison. Would you agree that both classes, on average, got about 50 in the test?
Yeah.
Because their medians are both 50, right? Which of the two classes had a much bigger variation?
B.
B. Now, can you tell that the middle box is bigger? And if you want to, double down on that, aren't the tails bigger? So we could say that Class A and Class B, although superficially, if you just looked at what did the average of both classes get, would you agree that in Class B, there was much more variation in the scores? Somebody got nothing and somebody got 100%. Nobody in this class got close to 100 or 0, right? So this would be a gambling question. Which class would you want to be in? Now that'll tell me a little bit about your risk aversion. So I'm going to pick on somebody. ZM, because that's what the first two letters say. What would you be? Would you like to be in class A or in class B?
I'd rather be in class B
Why?
because I see that some students in class B were able to get 100%.
And you want to be one of those people.
Yeah.
Right, totally. That would be me, but that's me, I'm a gambler. Marie, what would you do?
I'd probably do class B as well, since there's the chance of getting 100, I think.
Right. Now, do you know some people, I haven't found anyone, and there might well be in this class, but they may not be sure, might choose A. And they might say, at least if I go into class A, I'll never get nothing. Right? There's always some, I'm probably going to get something. The test isn't that hard that I won't be able to get some of it, right? So if you don't like a class or you're not very good at a class, you might want, you know, the topic I should say, right? If you're not good at English, or if you're not comfortable at English, you might want to go into class A just because it won't be such a, you won't get so disappointed with your scores because at least they're not going to be zeros. But if you are into, I want to get 100, then you would do that. Imagine these two classes were at university and they were both degree classes. And you wanted to give people A, Bs and Cs, you know, and fails and so on, right, and things like that. Wouldn't it be unfair to just say 80 to 100 is an A, 60 to 100 is a B, 40 to 60 is a C, and anything else is a fail, right? Because if I was using this on each class, wouldn't it not be a fair way of grading? For instance, in class A, maybe that person would get an A. Wouldn't everybody else not get an A? Whereas in this second class here, wouldn't there be at least a few people getting an A? What about getting a B? Well, only those people there would get a B. Whereas wouldn't be a lot more people getting a B. So say if you were in this class and they graded it according to A, B, and C, and then you failed, wouldn't this poor class up here only get Bs and Cs, and then the rest would fail? And this class would get a few As, a lot of Bs, a fair amount of C's, and not many fails. So when you looked at the class report for those two classes, wouldn't one class look like it was better than the other? Oh, your class did well. You got 5 A's, 20 B's, 14 C's, and only 8 people failed. And then they look at the other person and say, hey, you got no A's in your class, 20 B's, 5 C's, and half your class failed. Can you see why it is important that if you're going to use scores to grade people, that you should try and at least standardize them to be fairer? And one of the ways they very often do it in university is that they standardize, they grade on a curve. And there's different ways to do that. I mean, the worst one I've seen, and I don't like this, but it's easy. The top 5 people in your class get an A. The next 10 people in your class get a B. The next 10 people get a C. The rest failed. Now, can you see if you did that, wouldn't it be, in one sense, if the classes were the same size, wouldn't you get the same number of A, B, C's and fails out of them? But what's unfair about that is, can't one class just have a lot more clever, for want of a better word, people in it than the other? And aren't they just getting penalised for being in a class with a lot of clever people in it? And if they'd went to the other class where all the football players are in it, you end up getting an A with the same kind of score that would have got you a B in the other class. You see, there's a lot of unfairness in that approach. But no matter how you do it, you end up generating unfairness in a different way. Do you know how they get around that problem in Scotland? Of how come, you know, Professor A grades really easily and Professor B is quite strict, and, you know, it's dead hard to get an A off one, and, you know, it's a lot easier than the other. In Scotland, when you do your exams, we do standardised exams. So what happens is that if you're doing your math class when you're 16, you do 3 levels of math class depending on your ability. You do, you know, the O grades. In England it's called the O grades at least. And the professor doesn't know, he doesn't give the exam. Somebody in Scotland makes a math exam, and every single student at the same time sits the exact same math exam. And those math exams are then sent to a central location, and then from there they go back out. And I've done this when I've taught in Scotland. You end up grading some kids from Aberdeen that you don't know who they are, and you just grade their paper and you give them their score, and that score is totally independent of the professor or anybody. And so when they get those scores, can you see that it's a bit like there was only one exam and everybody in Scotland took it? Can you see how easy it is now to fairly go A, B, and C? It doesn't matter if you were in a class with 22 geniuses. Do you know 22 of you get an A? Because you all sat the same exam and you're all going to get a really good score. And if you were in a class full of 22 football players, because I like picking on them, couldn't you end up with a class with 22 people failed? Well, hopefully you passed. And so that's how we do it in Scotland. We standardise all exams so that when you get your grades, they are done in that way. Now, you only have one exam a year, right? So the school does their own little exams within the school system, but the one that counts is the big one, the one that you do at the end. And I find that to be a very fair way of making sure there's not a thing, which I believe is quite severe in America, called grade inflation. There is no grade inflation in Scotland because of the way we do our exams. And so you could go back in 20 years, somebody who got an A, and today somebody got an A, same ability. That's why they both got the same grade. And the exams aren't easier or harder. They shouldn't be, at least. Are we cool? Have we learned some good stuff about box plots and comparisons? Let's do a comparison of temperatures, right? So this is 3 box plots on 3 different places. And since I have no imagination, these places are called A, B, and C. Right, and these are temperatures, and imagine there was numbers there, but we don't need the numbers really to answer the questions I'm going to do. We're going to do compare and contrast. So these are 3 places. Based on the box plot, which place has the highest average temperature?
C?
No. Average temperature.
A. It would be A.
A.
No. Therefore, it must be B.
B?
B.
Why is it B?
Do you see the median?
Oh, okay.
Okay, gotcha.
When you say average, the average doesn't mean the whole picture. It doesn't mean how far to the end it goes. It doesn't even mean how big the box is. The average is, in this case, I should have said the word median, but I wanted to say the word average, so you would have to say, oh, in a box plot, that means the median, right? And is it the biggest one? The biggest temperature. So now that I've asked that, the next question should be much easier. What is it, young lady? I am having a meeting right now. I know. Yeah, I know. Well, come on, let's go. Come on, Billy. Let's go. You too. Don't give me the big sad eyes. Come on, let's go. Okay, watch this. Yummies. Yummies. Come on. There we go. Suckers. I only use the word yummies when I give them treats. So they're out there thinking, hey, where did he go? Okay, back to this question. I've almost forgotten what it was now. Okay, which one of these three places has the coldest average temperature?
C.
A.
C?
C.
C.
Look at where this is. And remember, you know, although there's not a scale here, would you agree big goes that way and right, small goes that way, right? So if I was saying put these in order from highest average to lowest average, you would say B is highest, A is in the middle, and C is the lowest average. Right, let's try a different question. And think lawyer, every word's a prisoner. Which one of these three places has the highest temperature?
That would be C, right?
That would be C, yes. Now, you got to remember, this box plot was
Sorry.
made up of 365 days worth of temperatures, right? So January the 1st to, you know, December the 31st, and they created this. So this is a year's worth of temperature, right? That might help you see it. Now, in the same sense then, wouldn't B be the place with the coldest temperature?
That would be B.
That would be B. Which
So going
one of
back-
the...
Oh, go ahead.
Right, question?
So going back, so B would be the before we were saying that was the average temperature,
Yes.
and so now we're looking at the highest and lowest temperature.
Yes.
Okay, just want to make
Right.
sure.
Agreed? Right. Now, when you talk about variation or spread, sometimes they'll say which place had the biggest spread in temperature or which place had the biggest variation in temperature. They're really interchangeable words. Which one of those three would be the biggest variation in temperature?
C.
Agreed. Now, when you want to talk about the variation, it's best just to look at the box, because isn't this side with my finger where Q3 is, and isn't this where Q1 is? And isn't the measure when you use these guys called the interquartile range? And that becomes the longest box has got the biggest variation, right? The longest box. Because isn't the longest box going to be the biggest number, Q3 take away Q1, right? That's going to come from the longest box. So in this story, won't C have the greatest amount of variation? Which one would have the least amount of variation?
A.
A.
Are we getting better at reading these things now? Yeah. Which one of these guys then, let's do a different question. Which one of these three guys would probably be symmetric?
A.
Agreed. Which one of these guys would be skewed right?
C.
And obviously the last question would have been what's going to be skewed left, and it would be B. So as you say, we can compare, we can contrast, we can look at how one is a larger average than the others, how one has more spread than the others. I'm going to put some stories to these places. Can you imagine this place is Hawaii? That's 80 degrees, and it doesn't vary that much. Most of Hawaii is what, 60 to 100 or whatever it is, right? 50 to 70, right? Very compact, very similar weather one day to the other. Do you know a lot of islands tend to get that kind of weather scheme? So if you're on an island, don't you tend to not have a great extreme from one side to the other? You can be in an island where it's freezing cold, right? Be in an island in Antarctica, right? The temperatures don't vary much, right? But they're always cold. But being a nice place, that would be Hawaii. Now, I'm looking for a place that would look like C. So this would have to be. It could be, I guess. You know, pick a day. It could be 60 degrees today and 85 degrees tomorrow. You could get some really cold temperatures in the winter, and then now and again you might get a 90 because you're really lucky. I mean, while looking at this place, it looks to me like there's a bigger variation, isn't there, on the larger than the average? So you tend to have a lot more variation on how hot it's going to be, but not as much variation on how cold it becomes, right? So half the year is going to be cold, but it's probably not going to be freezing that many times. But on the hot side, and I wouldn't call that hot, that average might be 60, right? From 60 upwards, there's a lot of days in the year where that can happen. That can even happen sometimes in September and in February, right? And right now our weather's been horrible, so I'm not sure it would have that shape. I wouldn't want to live here. If that number there is 80, would you agree that on the summer side, you get 80 and it varies, but it doesn't go that much higher than about 90 probably. But God, look at the winters.
Is that here?
I don't know. These are just made up pictures, but can you imagine? This would be a place where your summers are pretty much every day in the summer, give or take 5 or 10 degrees. That's what you get. But
I'd
the
say it's
winters,
Alaska.
that could be. Right, really nice summers, but they don't get extremely hot. But you can get some really stinking weather in the winter, and it can vary way down into the negatives even sometimes. So different places in the world. I have some moors here. Could someone look at the moors and tell me if there's any questions there that I need to answer? Because I can't really do it. If I go out, I have to go in and it's messy.
There's
Is there
nothing
any?
important in the chat.
Non-important, okay. If there is, yep. Tell me what they're trying to say and I'll answer it. Because some people don't have audio, which really you should have, but maybe it's not working today. Are we cool? Now, I want to show you how to test for outliers. Now, remember we had a list of numbers. If I can find them, I'll use them again, but I'm not sure we've got them. Okay, I'll start again. Let's suppose I have a list of data. And it looks like that. And we had to decide if 25 is an outlier or not. And at this point in time, we've really just been doing it subjectively. We've looked at this number and we've said, look, is it noticeably different from the next number? Is there a big gap before the 25? And the answer is yes, there is definitely a big gap there. And so that is a candidate for being an outlier. So far, so good? It's a candidate for being an outlier. The problem is that can be very subjective. Most people would say, if that was 250, I don't think I'd get an argument. Everybody would say, oh God, yeah, it's an outlier. If this number was 15, right? It's 25 right now. But if this number at the end was 15, is 10 to 15 a big enough gap to be a problem? Is it really an outlier or just a kind of big number? See, you're not sure. No, I don't think so. But there might be one or two of you here who thinks, yeah, I think it still might be. That's not a good way of deciding on an outlier, isn't it? Wouldn't it be much better if we had a test? And we do. And we have a test for outliers. And I'm going to show you the two tests. One of them uses the interquartile range, and the other test uses the standard deviation. The one that uses the interquartile range uses the interquartile range and the median. And the one that uses the standard deviation uses the standard deviation and the mean. Okay, So I'm going to take this data set that we have here, and I am going to find the interquartile range and the median. And then I'll tell you what the test is. So can you just trust me right now? I don't want to go out and in because it just takes up too much time. So I'm just going into the calculator right now and I'm going to do it. And if you want to do it with me to double check I'm doing it right, feel free. And I'm going to put all those numbers in and I'm going to check it out. So here goes. Although you can't see me, I'm putting in the numbers as we speak. 1, 3, 4, there goes 5, and 2 6s. An 8, a 10, and finally a 25. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I must have done it right. That's a good sign. And almost ready to tell you the answer. And, oops, where's my pen? Oh, here. Hey, where's my pen? How can I lose a pen and I've only got like 4 square feet in front of me? How on earth can I do that? It's a knack, I tell you. Okay. Can you remember the formula for the interquartile range was Q3 take away Q1? Now, although you can't see it, I'm reading it off, or I will be in a short moment in time. And Q3 is 9. And Q1 is 3.5 because the calculator tells me it is. And when I subtract one from the other, I get an interquartile range of 5.5. The median is 6. So according to the calculator then, an interquartile range of 5.5 and a median of 6. So we are going to get a guy, this is the test now, called the upper fence. And the upper fence oh, darn it. I'm going to have to do something here. If you hold on with me for just a few seconds. Just realized something. What I'm looking at is where on earth this question is, because there's something weird about it that I need to find. Darn it. Oh, I've got it. Okay. The upper fence is going to be Q3 take away 1.5 interquartile ranges. And there's another guy called the lower fence. And it's going to be Q1 take a, what am I saying take away?
Oh, we can't see your picture.
Thank you. I will come back and show you what it is then. I'll have to close this off. I had to go in and check because I was just a little bit curious, and I'm glad I did check on how they written, what they called it and how they wrote it down. I was about to call it an upper fence, which is actually what they did call it, which is good news. But they don't call it a box and whiskers, so I was just worried that they might have called, I don't know, the upper number and the lower number or some weird thing, and then I call it this and you go and you say I don't know what that is because you called it something else. So this is called the upper fence and this is called the lower fence. So let's get the upper fence. I wish I'd give myself some more room. So the upper fence is Q3 which on my calculator is 9. Take away 1.5 interquartile ranges, which is 5.5.
I still can't see what you're writing.
God, you lot are pushy. Thank you for, I didn't know. Please keep doing that, because I do forget very easily. Right, so there's the Q3. I'm going to take away, subtract 1.5 interquartile ranges. So it's going to be, I guess I could do it here, 9 take away 1.5 times, I keep saying take away, I don't know where my brain is today. So it's going to be 1.5 times 5.5. And that gets me 8.25. And this leaves me with 17.25. What does that number called the upper fence tell me? I'm a kind of visual person. Can you imagine you've got your data and at this point here, there's a fence. Anybody out here
It's an outlier.
is now an outlier. So does 25 count as an outlier now? Yes. Does 18 count as an outlier? Yes. But does 17 count as an outlier? It's here.
Quick question though.
Yes.
What using a Q3 plus 1.5? What's the 1.5? Is that just the formula?
It's
that
an
you use?
arbitrary constant that mathematicians kind of argued about for a little while and said, hey guys, look, how big do you think an outlier should be? And some people are saying, I think 2 interquartile ranges. And a lot of people, oh, come on. Yeah. Other people might say, no, what about 1 then? No, it's not enough. Okay, how about 1.5? All right, we'll do it. Right, it's quite arbitrary. Right?
Okay.
If I was doing this for the first time, you know, if I was the guy in charge of this, I might have decided 2 because I felt 2 was, you know, I wanted an outlier to be really outlierish. There's no such word, right? But you can get the idea. So now we have a perfect, unbiased way of deciding who is outliers and who is not. You find the thing called the upper fence using this calculation. In this case, it ends up being 17.5. Any data point that is bigger than 17.25 will be an outlier. So in this case, it was 25. Suppose I squeezed in another number here. Suppose there was an extra number. All the data pretends remained the same. If it was 18, it would still be an outlier. Agreed? If it was 17, it would not be an outlier. And now there's no subjectivity about it, right? We all in the scientific world have agreed to stick to the same rule, right? It's like standardized. Math loves this. Do you know we love to standardize things so that everybody in the world agrees with a particular way of doing something, and now nobody argues. So if you're doing a report and you decided that a certain value was an outlier and you were choosing not to use it in your analysis because it was like a Bill Gates effect thing, right? You didn't want it to distort the rest of what you were doing. You would simply just quote the fact that 25 is an outlier and it was removed because I did the lower or upper fence test on it. Now, for completeness sake, I think we should do the lower fence as well, because I keep wanting to write it down anyway. It's Q1 take away 1.5 interquartile ranges, so there is a kind of symmetry to it. Q1 is 3.5, and you're going to have to subtract here 8.25. So in this case, you're going to get a really weird answer, but I'm going to put it in anyway. 3.5 subtract 8.25, and the answer I get is negative 4.75. Now, what that would mean is over here, now you'd have 0 about here, but over here, you have a number negative 4.75. And can you see now that the outliers live here? So can you imagine these numbers were temperatures then, right? That way I can imagine a negative happening. Would -4 count as an outlier? No. Would -10 count as an outlier? Do you see that we now have an unbiased way for everyone to agree who in your data set is an outlier and who is not an outlier?
So if you get something that's right on the line, so say you do
Yeah, because that can happen. Yeah.
So say you do get 17.25 or you get -4.75.
The rule is you have to be bigger than the fence.
Okay.
So if you are a 17.2, I can imagine, especially when that number is a whole number like 20, right? I can imagine you could get a 20. The rule is if you're equal to it, you're okay. You're still not an outlier. So you have to be greater than the fence to be a large outlier, or less than the fence to be another one. Does that make sense? Right. Now, I don't think the textbook goes into what I'm about to do quite as deeply, but I think it's worthwhile knowing. Suppose you do have an outlier. For instance, see this guy here, he is an outlier. If you use your outlier in your box and whiskers, what you very often get, and I'm exaggerating it here. Wow. Is that, can you imagine that 25 makes this tail seem extremely long? Secondly, if the outlier is really, really big, can't your box plot be unreadable because the number's so big that there's no room to show it? It's not uncommon that when you have an outlier, you remove it and you do the box plot without the outlier. So you draw the picture with all the data, but you stop at 10. And then down at the bottom, you put a little asterisk and you say 25 is an outlier. Now, do you see what that allows you to do is, doesn't it allow you to look at the shape of what the real data looks like, right? All the other numbers. And then you can look at that and say, well, you know, that data is really, it's pretty symmetric. It just happened to have one weird outlier that, you know, screwed up what I thought the shape was looking like. And that kind of makes sense. That you may want to choose to remove an outlier from your box and whiskers picture, especially the Bill Gates kind of outliers. You know, if you tried to do a box plot with Bill Gates money, it would look like this. See that thing there? You'd have to have a microscope to go in to see it before you actually saw what that bar chart, what it looked like. So bear that in mind if you ever want to draw a picture of data, that a box plot is actually quite a cool way of doing it. A box and whiskers. Has anyone seen a box and whiskers in a science class or a geography class or somewhere? Right. Zoe, you want to share? Can you remember where you saw it, what it was about?
I've seen them in political science classes.
So did they use that to represent, I don't know, the views of different people? Like what males thought about something, what females thought, or some topic like that perhaps?
Yeah, it was mostly about like polling data and voter practices.
Right. So there's quite a big overlap in that class and this class. Pity you didn't take this class first, because it might have made that class a lot easier.
It probably would have.
Yeah, but yeah, you don't know that now. Are we comfortable with that? Now, I haven't talked about the small outliers, but you can imagine they do exactly the same thing, right? They can make your picture look so hard to get any information that you might want to drop it.
Can data still be skewed left or right if you take out the outlier?
It could be, right?
Okay.
Can you imagine I have a whole load of data that was, yeah, let me try and make some data that might look like that. That data there is skewed to the right. It does have an outlier. reasonably confident, but I'm not 100% sure that 20 is an outlier, right? But I'm reasonably confident it is. If I took that out and did a box plot of that, I'm pretty sure it would still be skewed to the right. So removing an outlier is meant to help you see what the real shape of the data is. You don't want one number to confuse the issue. So if you remove it and you do a box plot without it, you very often get a better insight into what it is like. Because if I tried to do this data, right, with the number 20, it probably would work, and it would just look, well, I'm running short of room. It probably look like where my finger is and you can't see it right now. It would have extended this tail. That in this particular example, that wouldn't have been a big deal. Can you imagine in other situations where it looks skewed to the right, but when you take the outlier out, it actually is pretty symmetric, for instance. I don't think something that looks skewed right, when you take the outlier out, will then miraculously now look skewed left. I don't think that is likely to ever happen, but it might look more symmetric when you do it. That certainly could happen.
Okay, thank you.
Now, we're going to do a test for outlier. Using standard deviation and mean. Okay, now I have that data that we had originally, which is this set of numbers here, right? And I'm going to go back and get that information that I need and tell you that the mean of this data was about 7.6, and that the standard deviation of this sample ended up being, it's about 7.1, but I'll just call it 7, right? It's darn close to being 7. So far, so good. Now, what is the test here? Well, they don't call it upper fence and lower fence. At least I don't call it that. And I'm not going to do that out and in again. If they do call it that, fine, but I wouldn't call it that, right? Basically, what you do is you take the standard deviation and you add 1.5 of those guys. Does that look familiar? Mean 1.5 interquartile ranges. Mean, take away 1.5 interquartile ranges. Now, I'm not going to call this upper fence and lower fence, because if I do that, then you might mistakenly think that you're going to get exactly the same numbers that we got a moment ago. But we won't, right? There will be a little wiggle room in them. So in this particular case, this is going to be 7.6, add 1.5 times 7. And you should get the same question. What about this 1.5? Well, here's an annoyance. That's not standard. That's actually what this book decided. If you look in other textbooks, it's 2. If you look in other textbooks, it's 3. So what happened there? We never got a consensus amongst the statisticians, right? When they got together and they went and did the interquartile range, I guess they got in quick and we kind of battered it through and we all agreed. And every textbook I've ever seen, at least 1.5 IQRs is what I've noticed, right? But not in this one. Maybe some people just said, no, I'm not accepting 1.5. It's got to be 2. 1.5 just isn't big enough. I don't think that's an outlier. And they weren't going to shift it, right? Yeah, I'll make this up because I know it's not true. Americans said 1.5 and the French said 2. The French are not going to do what you want and you're not going to do what the French want, right? And then the British went and said, well, ha ha, we think it's 3, so stick both of you, right? And so nobody now is ever going to agree. So in this second case, you have to really read the small print if you're looking at some information. Why did you say that's an outlier? You should be telling them you're using this test, or I'm using 2 times, or I'm using 3 times, right? Because that's the 3 tests that are out there. So, God, I never did this the way I probably should have, but I'm going to do it anyway. As a complete calculation then, right off the top, 7.6 add 1.5 times 7. The answer I'm looking at here is 18.1. So if I draw my little number line thing, here is 18.1. There's my little wall. You're an outsider, right? Or I should actually call it an outlier. There we go. Is 25 an outlier? Yes. Is 18 an outlier? Do you notice that the test that we used with the standard deviation did not generate the same boundary point? I'm calling this a boundary point than the other one. Do you see then that you could, in certain circumstances, call something an outlier because you used one test, but in a totally different circumstance, you might not call it an outlier because you used a different test? It's rather annoying, isn't it, that a number that's, you know, close to the boundary can sometimes be called an outlier and sometimes not be called an outlier. We just have to live with that. I mean, it's just going to happen. If you're using the interquartile range test, won't you get slightly different numbers than when you use the mean standard deviation? Right, just going to happen. And that's life, right? It just happens. We'll live with it. But at least we have got a standardized or pseudo-standardized rule for it. And when you do the ones in this book, will you just pretend that's the only test in the world so you get the answer right? And be aware that there's others, even though you'll never use them in this class for the homework, because that's not the way this book decides it's going to do that. I want to share something with you since we're in this part of the world. What have I just written down there?
3 times 1 and 3.1.
And would you agree that this is 3 times 1? And this is 3.1. Now, since you live in America, and most of you, I'm assuming, were born in America, you don't even think twice about that. Right? Well, I'm Scottish, which is part of Britain. That's 3.1. Our decimal point is in the middle.
I was picking up on that whenever you wrote. I was like, huh, wait a minute. That decimal point.
Yeah, I apologize for that, because you got to figure out, I've been writing decimals in Britain a lot longer than I've been writing decimals in America. Have you noticed that my decimal point kind of moves up, which is what someone was just saying?
Yes, and it's awesome.
Do you now know why it moves up? Because I think I'm writing 3.1, which I am.
Yeah, that makes sense. I got caught like that too, and I came back. I went to the bathroom and came back, and I seen a whole bunch of times, and I didn't know they were times, and I found out they were decimals.
Right. I wish I could fix it, but you know, I think there are certain things that when you get to my age are probably not going to get fixed. I'll try my best to do my decimal points low, but they're not going to work. Here's the history behind it. Do you know when America was part of Britain? You put your decimal points the same place we did because you were British, right? And then you became American. And for no particular reason, didn't your decimal point kind of drop down? Now, once that happens, it's very difficult to stop. Do you think the Americans are going to move their decimal point to where people in Britain put it? Do you think British people are going to move it down to where you do it? What have I just written down?
$3,123.
Unless you're French. Because I have just written down.
What? No.
Nod your head. Has anybody been to France? Don't they put a comma where a decimal point goes? Marie, you're
Just
nodding. Do you know
bonkers.
that from some reason, or you've seen that?
I think I've seen it somewhere. It's been a while since I went to France, but
Right. If you watch a French movie or a movie in a foreign country like France, look at the background when they're passing by the coffee shop, and they'll find that things cost that.
They do it in Canada sometimes.
Do you see that in Canada as well? Of course, because they have a French part to Canada, don't they? The French, is it Quebec side or something?
In Montreal.
Montreal. So can you see what a simple thing like not having agreed early enough on what a decimal point means, that the confusion that it causes? It doesn't tend to cause confusion within your country because everybody writes it the same way, and you get that false impression that the world must be doing it like that. But can you imagine that an American company got an order from a French company saying, we would like 10 pipes, 3,123 meters long. The American company is going to go, what? That would go round the world. And they weren't asking for anything really that big, were they? So the rule behind this is, shouldn't it be the case that we should standardize everything in math? So let me get back to my pet peeve. That guy should be 3. Because back home, we use 3. And if everybody else decides to use 3, won't that make our life easy? And I've just noticed, do you see my 1.5 and my 7.6 and my 8.1?
Yeah, that's when I came back to the bathroom and I seen that and I was like, wait a minute, it's 1.5, but it's 1 times 5, so which one is it?
Right. Do you now notice my decimal points kind of, at least some of them, am I not trying to move them a little bit lower than the middle? I think in my 7.6, at least there was an attempt. I think my 18.1 was a little bit better. And yeah, I kind of lost it on the 1.5, right? So I guess this is good because from now on, when you go back and look at some of my notes, oh, he didn't mean 1 times 5, he meant 1.5. Okay. Did that confuse anybody last week when I was writing down? Or did you just suddenly get used to it and notice that I meant decimals because I said it?
I honestly didn't even notice.
See, that's a good sign then. So it didn't cause a problem. You know, once you come acclimatized to it, it is not a big deal. Okay. Have we any questions then about how you decide what is an outlier and the 2 different tests that we use and we're using? Yes.
So is there a preferred way, or are there circumstances in which you would say, oh, I need to do this through the IQR way?
No, it's really, if you're collecting your data and you decide to summarize it with a 5-figure summary, and then from there you then create, say, a box and whiskers, you're probably going to use the IQR version, aren't you? Because the data is already in that format. If you were taking your data and you were going to use the mean and the standard deviation as your 2 measures of center and spread, and you were then going to do some histograms, you know, something like that, you would probably be using the the mean plus 1.5 standard deviations. So it really depends on the measure of center and spread that you're going to use. Typically, you only pick one or the other. right? You decide I'm going to use the median and the interquartile range as my measure of center and spread, or you're going to use the mean and standard deviation, right? They kind of go together as little husband and wife teams, right? And once you've decided that, then you kind of have decided which test you're going to use for outliers as well. There's not an awful lot of sense in using interquartile range in box plots, but using the X bar 1.5 standard deviation as your test for outliers. And it's a bit like mixing and mixing up your cake mixture, right? You're making a bread and you're making a cake, and now you're kind of adding raisins to your bread or whatever. Bad analogy, I can't think of a good one. So that's the answer. Stick to whatever you're using as your center and spread, and use that version as your test for outliers. Can you have more than one outlier? Yeah. Do you know if you have a really big data set, like 5 million people, can you get 10,000 outliers? Right. So you make a little fence if you're using the upper fence, and you got a whole chunk of outliers. Normally, when you get to huge data sets like that, you don't do it by hand, right? You get a piece of software, and the software generates it, and the software will have various choices that it gives you. It might say, do you want to just do a box plot using all the numbers? And you say yes. And you look at the box plot and you think, oh God, Bill Gates has screwed that picture up. And so you go back and you do it again. And it says, do you want to use outliers or not? And you say, no, don't use the outliers. And it does another box plot. And you say, yeah, that makes more sense. I can see a picture of the data now, whereas before I couldn't. And the same kind of things that do box plots, software does histograms. If you're into Excel, for instance, it does both of those. So if you, in the future when you've got time and you want to make maybe cleaner looking ones, with the best world in the world, when you do something by hand, doesn't it look less professional than if you get some piece of software to do it, right? So if you in the future have to do a box plot, you might want to look up how do you get to do it using Excel as one way of doing it. If you really get into statistics, there's lots of statistical packages, they're called, the software packages, that pretty much do everything under the sun you could possibly want. And they will produce pictures for you that are really detailed and really colorful as well, right? They can put color in them and, perspective and who knows what else, right? So what else? I think I've covered all of that. I'm going to go in, if you can wait for a few moments, and we'll look at the homework question, because that's my way of figuring out, did I miss anything? In which case I'll say, oh, I forgot to tell you about this. Okay. So if we hold on a few seconds, are you looking at the homework up to 3-3 box plots? Right. So let's look at that one, and then I'll go backwards and look at measures of variation. And I'm just doing that because it's freshest in my brain. And here we go. And I already have found something I forgot to talk to you about. So let's talk about it right now. Can you see question 1? Do I have to go out and in? Okay. Let me do that first then. I'm out. And I can't find it. I'm in. There we go. You can see it now, right? So Angela took a general aptitude test and she scored in the 89th percentile. I forgot to talk about percentiles. I guess it's because I just overlooked it. What percentage of the score were below her score? Do you know 89th percentile means that you are like the 80, imagine there's 100 people, there's an analogy. The 89th percentile means you were the 89th person, right? In the list, you were 89th, right? Good, right? 100 was, I got 100, right? And so on. So that would be 89%. So what percentage scores were above and what were below, right? So what percentage of scores were at or below her score. That's going to be 89, right? And which ones were above are going to be the other 11. Oops, hit the wrong button. The other 11. So if you did your SAT score and you were the 95th percentile, wouldn't that make you in the top 5? I see puzzled looks there. Is it just that the picture's so small, or are you getting what I'm saying? Okay.
Yeah, that would, because that means you scored better than 95 other people, right?
Yeah.
So top 5.
Top 5. Make sense? Right. Let me go out and then I'll come back to that one then. I'm going to do some examples of that just to try and emphasize it, because one example might not be enough. One way of telling a person, say in a test or in anything, is a term called the percentile. So if I say that your height is in the 90th percentile, 0 would be the smallest person in America, whatever height they are, and 100th percentile would mean you were the top person, the tallest. And the 90th percentile is you, and you are there. That means that there are 90% who are less than you, and there are 10% that did better than you, if being tall is a good, bad thing, right? Do you know something special about really tall people? They're the first ones to find out that it's raining, and they're the last ones to know that it's a flood. No, I just thought I'd throw that in. Okay. So, if you were in the 25th percentile, which would be very roughly about here, right? Can you see that only 25% of the population would be smaller than you, right, on this side? And on this side here, wouldn't 75% of the population be bigger than you? Do you get the idea of what a percentile is telling you? It's kind of telling you in the position of the world where you lie. Now, if I do it doesn't need to be symmetric because it just doesn't need to be. And can I tell you that this is a box plot, and let's say that's 0, this is 30, this is 40, this is 60, and this is 90, right? And these were scores in a test. Do you know the person here who got 30 in the test? They are the 25th percentile. How do I know that this guy, who by the way is called Q1, why that's the 25th percentile? How do I know that? You may have been saying something, but I haven't heard any answers. I see lips moving, but not, I can't hear it. Okay. Do you know when you do a box plot that you actually break the data into quarters? That's why this is called Q1. That's why the median is sometimes called Q2, and that's why this is called Q3. So won't the 25th percentile be here? That means 25% of the numbers are in this range. So people who got 0 to 30 in the test, that was the first 25% of the class. Now, if you want to do this fella in the middle, right, the guy we call the median, isn't the median also going to be the 50th percentile? Now, does the median being the 50th percentile kind of make sense? Can you imagine you've got all the number? Isn't the middle guy the median? But isn't the middle guy 50% of the people? So you can look at Q1 is meaning 25th percentile. Q2, the median, is being the 50th percentile. And whatever, in this case, Q3, wouldn't that guy over here be the 75th percentile? Right. Are we a bit more comfortable now about the percentile questions? Right, let's go back and I don't think I missed anything major, but who knows? Let's go back and see what else they have for us. I think it's here. Okay, so one standard for admission into Redfield College is that the students must rank in the upper quartile of his or her graduating class. Upper quartile. What guy do you think they mean by that? Quartile.
Is it the 75th percentile?
Yes. They have to be in the upper quarter, the top 1/4. And remember, the top 1/4 is called the 75th percentile. Okay? So that's what that one is about. A town of Butler, Nebraska has decided to give a teacher competency exam. God, I would feel that. And defined the passing scores to be those in the 70th percentile or higher. Whoa. Do you know if you make the passing score the 70th percentile, doesn't that mean only 30% of the people are going to pass it, no matter how good they are? Yeah, everybody takes a test and you have to be in the 70th percentile or higher, right? Isn't that the top 30% then? That doesn't seem very nice. The raw test scores range from 0 to 100. Was a raw score of 82 likely to pass you? Now you might say, well, 82 is bigger than 75, but the question doesn't, or 82 is bigger than 70, but that doesn't necessarily mean that you're in the 70th percentile. Couldn't you get 82 in a dead easy test and be in the 50th percentile? Half the class got that. Couldn't you be 82 and be the top score in an exam? Right, the best person got 82. So do you see a raw score, whatever that number is, even if that number is out of 100, a raw score is not the same as a percentile. To get a percentile, don't you have to think of the data more like in a box and whisker diagram, or at least in some kind of way that looks like that? And then they give you some scores, and I'm not going to talk about them. One of them's right, and you can figure it out. Now, here is a pretty standard question, which I like. Do you see we have data here, and you type in all the numbers? We call that a 5-figure summary. There's your interquartile range. What you're meant to do is draw the picture, and then you pick the right one. I know this isn't the one unless I'm lucky, but if you draw it in your square paper, can you see that's the guy that you would choose if he was right? So let's find out. It starts at 4 and it finishes at 12. Well, that didn't help me much. Don't they all start at 4 and finish at 12, right? Wouldn't I need to know what the median is? And that might make me figure out which one's the right one. But one of these pictures is correct, and you pick it. Now, suppose this was a question that you got in your midterm or your final. All I would see, and I'm making this up, so don't pretend that it's right, because it's just made up numbers so I can talk about what you might get. Now, pretend that data, the 5-figure summary, is correct. Is my interquartile range correct? Is the interquartile range based on the numbers that are here? Is it in fact 6, or did I make a mistake?
I can't see any numbers.
A bit louder, Zoe.
I can't see any of the numbers.
Oh, can you see the question?
Yes.
Darn it.
I can see the
I'm-
numbers.
I can see the numbers.
I can see them.
Oh God, thank goodness for
Forget
that.
me.
I know that I'm glad you can't see the numbers because it maybe you just have to refresh your screen or something as well. Okay, and back to this question then, would you agree that the QR interquartile range is not 6?
Wouldn't it be 5?
It should be 5, right? Now, why am I getting at? When you're doing your test, you only type in some numbers and you pick a picture. You will also be doing working, especially when it comes to calculating the interquartile range. Now, although you can do it in your head, what you should do for the test, you don't need to do it for the homework, but for the test, IQR equals Q3 take away Q1 equals 11 take away 6 equals 5. Now, apart from writing that will make you probably do the right answer. See if you say equals 6 and you put the box and you put 6 in there. When I go and look at your working, I will say she knew what she was doing. She just, you know, was a bit forgetful and she forgot to subtract it correctly. If you leave the wrong answer in one of these questions, have you noticed that it is very cruel? If you get one piece wrong, it can come back and say 0 out of 6 for the whole question because one piece of it wasn't right. You know, especially if there's 5 answers. Now, you don't want that to happen, so I need to see your working to make sure that's correct. Secondly, I need to see your picture so that I can compare it to what you said the answer was. Because I could imagine that you might draw the right picture, but just in the heat of the moment that you picked that one because you thought that dot meant this picture. You know, can happen, right? Especially if they're on top of each other, like 1, 2, 3, 4. Sometimes you don't know which dot is which picture. Well, you know, in this, if you just do that, the book will say you're wrong and you lose points. And off you go and get it. Now, I don't know which one of these is the right one, so you're going to have to figure that out. With a small data set like that, could you just do these things by hand? Or you could put them into the calculator. That's your choice. Whatever you feel like doing.
Do we need to show work for the median?
No, because won't these guys be probably done in your calculator? Right, now if they are not done in your calculator, then I guess I would see working because you had to do it by paper, right? So certain things I can't see working for, I understand that. So be careful. But things like interquartile range, pictures, I could see working for. Can you imagine there might be a question later on, is 45 an outlier? Do you see in that question, you would just say yes or no on the homework, right? It'll be a little circle yes, a little circle no, and you pick one. But in our world, wouldn't you have to do that upper fence thing or whatever, and some calculations, and then you'd come up with your conclusion. So not every single thing has working, you're right. Some things, you just have to be careful. Right, in this set of data here, I would definitely do it in the calculator, right? It's too many numbers and they're all jumbled up. And one of these 4 pictures will be the right one. And whatever it is, you do that. And interquartile range is 8, you would do that. In fact, if you wanted to do this picture, right, a box plot, wouldn't you have to find Q1, Q2, Q3 and all those things to be able to do that? So it's not that much extra to figure out what the interquartile range is. It would just be Q3, Q1. Here's pick a picture. Now, in this question, here is one of these is the right answer. Here is the other one. It's going to be that compare and contrast thing. So let me just pretend that this picture here is the right answer and this is the other hospital. So we've got this guy and we've got this guy. If I was going to look at these, discuss things, how about the median of this one is roughly about 25? Does this one look to be about the same, about 25? So I would say the median in both hospitals is about the same. So on average, they treat about the same number of patients. would you agree that this shape, this box, and then compare it to this box, would you agree that this has got more variation? Right. The distance between the start of a box and the finish of a box, if it's big, it means it's very varied, right? There are a lot of different numbers. And in the second one, it's quite small. And so I would talk about the variation on hospital B was different than A. So if these were hospitals and how many patients they received every day, right? I would describe both hospitals as on average receiving about the same number of patients every day, but the top hospital, the one up here, or sorry, the bottom hospital, the one down here, has much more variation, right? So some days it's really, really quiet and they only have like 13 or 14 people turn up, and then other days it's 30 odds, right? It's a lot more. And that just gets typed in there. Same data, or bigger and bigger, fill it in. Oh, here's one at least we can do a compare and contrast to. The Consumer Reports rated in automobile assurance companies and gave annual premiums for top-rated companies in several states. The figure below shows some box plots for annual premiums for urban customers, right? I guess that's people who live in urban, rural cities and towns, right? Rather than those people who live, way out in the middle of nowhere. And this is for a married couple with one 17-year-old son. So I guess they're just making sure that they're comparing insurance rates one with the other. Well, there is no indication in numbers here, but I can look at these and I can look at Texas, I can look at Pennsylvania, and I can look at California. And a couple of things come to mind. Would you agree that Pennsylvania seems to be charging much higher insurance premiums, right, than the other two states? Is there anybody who knows enough about America? Because I don't. Why is Pennsylvania likely to do that? That's not part of the question. I'm just throwing that out there. What's special about Pennsylvania? Say again?
It's on the East Coast.
It's because their living is so damn high.
Their living?
Their cost of living is ridiculous for a one-bedroom apartment. I have family who lives there.
Right. It's just everything is expensive, right? And so if everything's expensive, a pint of milk is expensive, getting on the bus is expensive, going to McDonald's, who knows, it's probably just, a McDonald's hamburger in Pennsylvania probably costs more than a hamburger from a McDonald's in Texas. Is that the kind of thing that happens over there?
Yes, actually, I've been to both. I have family in Pennsylvania and also Texas, and I've been to both. Texas is way cheaper than Pennsylvania.
Right, houses are cheaper. Now, before you start saying, why on earth is anybody living in Pennsylvania, can I qualify that with the fact that you probably make more money doing the same job in Pennsylvania? So the policemen get higher salaries, and not everybody, because nothing's perfect in this world. But would that be a fair representation? If you got a job in Pennsylvania, would it probably pay higher than the same equivalent job in Texas?
Most definitely.
Yeah, I agree. I have family in Delaware, and I used to work in Pennsylvania, so I made more money in Pennsylvania than Delaware.
Right. Would that also be true that the minimum wage in Pennsylvania is a higher minimum wage than Texas? Would that be a fair assumption?
Oh yeah, Texas is minimum wage is $7.25 an hour.
Right, and in Pennsylvania, it's what, I don't know, $12. I'm making up a number, right?
Something like that.
Yeah. Can you see?
75.
Right. Do you know that piece of information makes me think of something? Do you see why politicians should be kept out of minimum wages? Suppose you made the minimum wage $10 for every single state. Well, people in Texas would like that idea because they get more money. But don't people in Texas have a lower cost of living?
Yes. Housing is extremely cheap.
Right. So do you see in a way that's unfair to Pennsylvanians? Let's suppose the government decided to be fair, inverted commas. They always want to do things for the right reason, but they screw up. Suppose they said, let's be fair. Mathematics professors at community colleges do the exact same job, whether they work in Pennsylvania, Texas, or Washington. Therefore, every single one of them should get $80,000 a year as a salary. That's a kind of equality argument, isn't it? Same job, should get paid the same amount. Isn't that a kind of argument that certain political viewpoints make? I don't want to be a math professor in Pennsylvania. I want to be a math professor in Texas. Because won't my salary give me a better standard of living because the houses are cheaper and the McDonald's are cheaper and everything else is cheaper?
Yes.
Do you see how unfair it is sometimes to make things the same? Life is much more complicated than that. So this is me being political here, and I apologize for that, but I'm a proviso. Everything I'm about to say is totally wrong if you don't believe it. And I'm just stupid, right? And that is totally acceptable. But my opinion is that politicians should be kept away from making any decisions except the basic ones, because they're really bad at it. Most politicians couldn't run a business to save their life. In fact, if you put them in charge of a business, half of them would end up going bankrupt. In fact, if you look at some of the politicians that are in power, a large number of them have been bankrupt at least once in their life. That's how good they are. So just don't let them do things. I'm a great believer that people make better decisions than politicians do. And that's just my viewpoint. I'm also a great believer in don't make laws unless you really have to. Because I think when people make laws, I lose a little freedom. Every law tends to stop me doing something I want to do. Can you think of many laws that say, hey, you can now do this? That's not kind of how laws work. Don't laws say you have to wear seatbelts? Which, by the way, not all laws are bad, right? I understand that. But I don't see why I should be given certain laws that tell me that I should be doing things when, if it doesn't affect anyone else except me, and I have to pay for the consequences, then I should be allowed to do it. That's kind of my viewpoint in life. Oh, I got one vote. Okay, you're going to vote for me, right? So when I go into politics, by the way, if I ever do go into politics, do not vote for me. I would be a horrible politician. I am far too opinionated.
Professor Robertson for prize.
What? Oh, you're going to make me a president? I'm not allowed to be. I'm not an American citizen, which is another reason don't vote for me, because it's illegal to do it. It's illegal for me to have a political office because I'm not an American. Anyway, okay, let's look at this one because it is interesting. So I drifted and I do. Which state has the highest medium premium? Pennsylvania. Gotcha. The other sets of figures given the 5-figure summaries generated by a TI-84, right? We've done that. Match the 5-figure summaries. So do you see this one here called A, and this one here called B, and this one here called C? These numbers were generating that picture. Okay, let's see if we can find Pennsylvania out of this. Which one of these three is Pennsylvania? A, B, or C? I can see the numbers. Can you see them? They're very faint grey. I don't know if that came up on the screen. So I maybe ask. Agreed. Can you see the maximum value on B is 7,527? Isn't that a bigger number than the other two? Now, when you look at the picture, doesn't that represent where this thing here is? So it's I like the kind of puzzles, right? Here's a picture. Here's some data. Can you figure out who's who? Right. So you can figure out the others. This question here is pretty standard. This is another one, and we are done. So I'm kind of happy that we've covered that one. If I can, for the next few minutes, go back now and look at the questions that have measures of variation in them. And I'll just scan through them in case I've forgotten something. I hope I haven't. I don't think I have. So a bit of luck, this will be much quicker. Right. Okay. Which average, mean, mode, or median do you normally partner with the standard deviation? Ah, I think I mentioned husband and wife today. And I said these two went together like husband and wife, and these other two things went together like husband and wife. Can you imagine who I went and stuck to with the standard deviation, who he or she was married to?
Would it be the mode?
I mean,
Would it
It's
be
a
the
mean.
median?
It's a mean.
Oh, mean.
The mean and standard deviation go together. And the median and the interquartile range go together is the other partnership. Okay. Now, I do notice that I've missed something, so I apologize. So I'm now going to fix that. There's a guy called variance that I never mentioned, mostly because you never use it. Variance is the square of your standard deviation. So see if your standard deviation was 5, your variance is 25. And variance is just another measurement of how varied something is. It's not used much. Standard deviation is much better. I did mention this guy, so I can skip by that. Suppose you take a set of data, a set of numbers, and I have missed something. And I know why I've missed it, because I did it with my night class and I didn't do it with you. So I am about to show you what I missed. But you could probably have figured it out even if I hadn't told you. Here are some numbers. 3, 7, 17, 40. 1, 2, 3, 4. Right, here are some numbers. The mean of these numbers is 40 divided by 5. The mean is 8, right? Okay. Suppose I took all of these numbers, every single one of them, and I added 8 to all of them. What would the new mean be? Well, I guess I could just do the thing, right? Call that 9, call that 10, 12, 18, 21, and just do it by hand. But I can actually tell you what the answer is going to be. It's going to be 16. So suppose I added 4 to all of them. Suppose I added 4 to every single one of these, and then I calculated what the new mean would be. And I'm going to tell you the answer is 12. Suppose that I added 10 to all of these numbers. Has anybody figured out how I can do that so quickly? Because I'm not turning them, I'm not doing it all in my head. I'm just doing a really quick shortcut.
You're adding to the 8, either it be 10, 8, or 4.
Yes. Do you know if you have a set of data and you add the same amount to all of them, doesn't the mean just increase by that same amount that you added to all of them? That makes sense? So if you took these numbers and you added 10 to all of them, do you know that your new mean would become 18? Does that kind of seem sensible? Yeah, that makes sense why that might happen. If every number is 5 more than it used to be, shouldn't the mean be 5 bigger than it used to be? Right? That's what I'm saying. What about this then? Suppose you double all the numbers. So 2, 4, 8, 20, 26. What do you think should happen to the mean?
It would double.
It does. And I'm only going to do one of these. If you treble all the numbers, won't the new mean be 24? You agree? Now, I'm not doing this because it's the same rule. Do you know if you take a set of numbers and you make a 5-figure summary, right? Max, min, Q1, Q2, and Q3, right? A 5-figure summary. Right? Imagine you did this to this set of data. Do you know if you added 8 to the numbers, wouldn't the 5-figure summary just have all its numbers added 8? Right? Everything would just move 8 upwards. Oh, would it work if you took 2 away from everything? Yeah. If you double everything, you double all the numbers in a 5-figure summary. If you treble all the numbers, you'll treble all the numbers in the 5-figure summary. So do you see that calculations like add, subtract, multiply, and divide, the statistics, that's what these guys are, right? Stay in lockstep with what you did to the data. So if I doubled the data, I'll double the mean. If I doubled the data, I'll double my Q1, right? And so on and so forth. Now, just when things are looking good, let's do standard deviation. Now, if you took a list of numbers like this, and let's just pretend that the standard deviation, well, let me bring it back down, you can see it. Let's pretend that the standard deviation was 3. Now, remember, the standard deviation is a measure of how spread out the numbers are. So if you took all these numbers and you added 8 to them, all that would happen is that the numbers that are here that look like that would end up over here looking like that. Do you see that the standard deviation is the same if you add numbers to all your data? So how spread out the data is does not get affected by adding or subtracting the same number to all the data. So you see how that's a little bit different. In the mean, it does change, but in the standard deviation, it doesn't. And the same thing's true for the interquartile range. It doesn't change if you add numbers. But what happens if you double all the numbers? Do you think the new standard deviation is still 3, or do you think that that changes?
Want to change to 6?
Yes. Well, let's try and argue why that's the case. Can you imagine that's my picture of the original numbers? When you double them, don't you also double the gaps between them? Don't they become twice as spread out because the numbers are twice as big? You know, the small number that's 2 becomes 4, but the big number that's 20 becomes 40. Do you see they're further away from each other? And when you double a 2, it's not as bad as doubling a 20. And so that is what that is about. I think they only have a couple of questions, and we are done.